Hello and welcome. I'm Amber Soto, the Director of Mathematics for iLead Schools. And today I want to talk about understanding change of base and binary systems. Now, many of you are just friends of mine that reached out and asked me to explain this. Did I go all extra and make a whole video just to explain it and a PowerPoint with it? Yes, I did. And if you know me well enough, you know that makes sense. All right, so let's talk about it. We use the base 10 system. That's our regular thing that we're all used to. Base 10 means we use 10 symbols. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. This is what we use on a regular basis. It's our base 10 system. So because of that, we can use 10 as a base of an exponential number for our number system. So what does this look like? This is what we're used to seeing. It's going to go in a weird order on purpose because this is what's familiar. Ones, tens, hundreds, thousands, and then on the other side, tenths and hundredths. Now, if we look at this in math language, tens can always be the base for every single one of these. 10 to the 0 is equal to 1. So that's where we get our ones. 10 to the 1 is 10. 10 squared is 100. 10 cubed is 1,000. And 10 to the negative 1 is tenths. 10 to the negative 2 is hundredths. So every single one of our buckets in our base 10 system, buckets meaning thousands, hundreds, tens, ones, the way you see it in number placement, is all based on 10 as the base with an exponent to go with it. So when we break up numbers like 324, for example, we would say the 3 is in the hundredths place, or we could say we have 3 hundreds or 3 times 100. 2 is in the tens place, so we have 2 tens or 20. And 4 is in the ones place, so we have 4 times 1, which is 4 singles. Mathematically, we could say 3 times 10 squared, because remember 10 squared is 100. So that's our hundreds place. 2 times 10 to the 1, 4 times 10 to the 0. Similarly, the number 1,579 and 6 hundredths would be written as 1,000, 5 hundreds, 7 tens, 9 ones, 0 tenths, and 6 hundredths. We would line it up in our little place value system, right? Mathematically, you can see the correlation. I tried to use the colors to go along so you could match it up. So thousands would be written as 10 cubed. Hundreds would be written as 10 squared. So if we have 5 hundreds, for example, we could say 5 times 10 squared. So how does this all relate to the binary system? Well, bi means 2. And so a binary system is a base 2 system, which means we only use 2 symbols. Can you guess what they are? 0 and 1. That makes sense, right? So where we use 10 as the base before, so thousands, hundreds, tens, ones is 10 raised to whatever exponent, we're now going to use 2. And it's going to look weird because we're not used to seeing these other numbers, but remember it's groups of 1, groups of tens, groups of hundreds. So with base 2, it's now ones, twos, fours, eights, and so on and so forth. And then on the other side, halves and fourths, because we're doing all of our work by twos. Our new buckets are of twos. So let's get to the point of where this all came from. This was a meme that was going around and it looks like you're adding wrong and it's hilarious because only zeros and ones are used. The assumption is that we're using a binary system here. Now that doesn't necessarily have to be true, but in this case, that's our assumption. So you can break these numbers down the same way we did to the base 10 numbers just now on slide 3. So let's look at that. If we take this first number and we put it in the buckets according to ones on the far right and move to the left, just like we do when we use base 10, we would have ones, and then times 2 would be twos, times 2 would be fours, times 2 would be eights. It's the base 10, the base 2 system. So we have 0 eights, 1 4, 1 2, and 1 1. See the 0 1 1 1 across the top of this first number over here. So 0 eights, 1 4 would be 4, 1 2 would be 2, and 1 1 is 1. We add those together just like in 324. It was 300 plus 20 plus 4. We got 324. Here we get 4 plus 2 plus 1 is 7. Okay, so that should come out to 7. Now, if you want to pause this video real quick and try to figure out what this second number would be on your own before I tell you, feel free, but let's go. I'm going to click now. So again, this time we have 1010. So that's 1 8, 0 4s, 1 2, and 0 1s. If we have one group of 8, it's 8. 0 groups of 4, it's 0. One group of 2 and 0 group of 1s. So we have 8 plus 0 plus 2 plus 0, which is 10 when you add it together. So now finally, you notice this down here is 5 spaces where we were working with 4. So what do you think this last space would be to the left? Well, if you guessed 16s, you're absolutely right, because we're going times 2 each time, right? So we have 1 0 0 0 1, 1 0 0 0 1. So we have 116, 0 for groups of 8s, 4s, or 2s, and 1 1. You add that together and look, 17. And if we were to add these, 7 plus 10, sure enough, we would get 17. So that checks out. All right. And you can actually apply the same method to any base of change, but for the sake of keeping things simple, I'm going to save that for another video. For now, let's just focus on this, keep it short and sweet. I hope you found this helpful. Most of you have my contact information, so if you have any questions at all still, don't hesitate to reach out. I'm always happy to help. Math is kind of my happy place, and so honestly, it's never a bother. All right, with that said, I hope this brings clarity. I hope it was a little bit fun for you. And as I always like to say, happy mathing.